Hello everyone, very good evening and welcome to the BYJU'S exam prep. This is Sanjay Rathi. How are you guys? Now questions from Sedran Smith, that is one very important topic for competitive exams, that is MOSFET, metal oxide semiconductor field effect transistor. Okay, and we have to solve some important numericals from this topic. I think all are ready to solve some questions with your copy, calculator and what scribble pad and so on. Then guys, questions from Sedran Smith. Why? Because normally we are getting questions from standard textbook like Sedran Smith, Millman, Helkias, and already I have solved questions from what network, that is from right, Alexander and Sadiku. Now this is time to solve some questions from analog, and standard textbook is Sedran Smith. All are ready now. First of all, this is my introduction. Myself Sanjay Rathi, and I am having 23 years of teaching experience. I have qualified and selected for engineering services exam. These are my ranks, and according to my experience, you have to solve some important numericals from standard textbook to crack any type of competitive exams and to crack what interview. अब आपका इसरो का भी आ गया नोटिफिकेशन, तो आप इसरो की भी तैयारी स्टार्ट कर सकते हैं. जस्ट गेट एग्जाम से पहले आपका वार्म अप हो जाएगा. तो जो एलिजिबल है इंतजार कीजिए. 17th ऑफ दिसंबर ये आपके लिए क्रूशियल डेट है फॉर इसरो एग्जामिनेशन. ओके, देन गाइज, this is my telegram channel. Already I have uploaded all the pdf of my previous session. Go through it, download the pdf and go through the session and try to solve those questions from standard textbook. Selected numericals, limited numericals you can solve easily. You can solve. PDFs are available as well as for daily dose to improve concept, for daily important questions, for latest information about the exam. That is my channel, Electronics by Sanjay Rathi. Then next thing, before starting the session, this is a national scholarship test for GATE exam. If you want to start your journey with us, then give this scholarship test and get up to 90% off on our program. Date 26th of November, timing 9 AM to 9 PM. Register now. This link is given in description. Window is open from 9 AM to 9 PM. एक आप टेस्ट अटेम्प्ट जरूर कीजिए, आपको पता चलेगा कि आपसे कितने क्वेश्चंस बन रहे हैं, और ये अच्छी गोल्डन अपॉर्चुनिटी है आप लोगों के लिए. उससे पहले आपको इंस्टॉल करना होगा राइट बायजूस एग्जाम प्रेप ऐप फ्रॉम गूगल प्ले स्टोर, जहां पर आपको टेस्ट देना है. देन सेकंड थिंग, इंपॉर्टेंट वन, बाय राकेश तलरेजा सर, वर्कशॉप on 22nd of November at 7:30 PM. Topic: comprehensive 1-year plan to conquer GATE 2025. तो ऐसे कितने लोग हैं जो गेट में टॉप रैंक लेकर आना चाहते हैं? उनको लगता है अभी बहुत टाइम है, एग्जाम तो 4 से 6 महीने में निकल जाएगा. बट रिमेंबर गाइस, दिस इज नॉट लाइक सेमेस्टर एग्जामिनेशन. अगर आप सेकेंड थर्ड ईयर से अपनी प्रिपरेशन स्टार्ट कर रहे हैं, या फाइनल ईयर में हैं, या आप जब जॉब में हैं, टारगेट करना है गेट 2025 to crack with what top rank, it is right time to start your preparation. Minimum 1 year चाहिए अगर आप जीरो से स्क्रैच से अपनी प्रिपरेशन स्टार्ट कर रहे हैं. तो वर्कशॉप में आप अपने क्वेश्चंस पूछिए, और भी आपको कोई डिटेल चाहिए तो वो सर बताएंगे. तो आइए रजिस्टर कीजिए अभी. अब ये है, दिस इज द फर्स्ट क्वेश्चन. ट्राई टू सॉल्व दिस क्वेश्चन एवरीवन. ट्राई टू सॉल्व दिस क्वेश्चन. यस प्लीज. What is the answer for this one? Then read question carefully. Okay. Now it is visible. Consider a process technology for which L minimum is given as 0.4 micrometer. That is the name of the process technology where the minimum length of channel possible is what? 0.4 micrometer. TOX is given as 8 nanometer. Mu n is given as 450 centimeter square per volt second. So normally that was the question in GATE exam. What is the mobility of electron in case of MOSFET? So that is in the range of what? 450 centimeter square per volt second. That is for what? Remember, this is for silicon. When we are talking about the BJT, that mobility is what? High, and that is because of what? Doping. Now, and Vt is equal to 0.7 volt. You have to find the COX and K and S. So first, very simple question, formula based. Second question, for the MOSFET with W by L. W by L is called aspect ratio. What is the given here? 8 micrometer upon 0.8 micrometer. Means that ratio is actually 10. 8 divided by 0.8 micrometer cancel out. Remember the W is 10 times of L. हमेशा देखो width ज़्यादा है as compared to L. Then calculate the values of VGS and VDS minimum needed to operate the transistor in saturation with a DC current of 100 microampere. So there are three regions in MOSFET. One is called triode, one is called saturation, and one is called what? Cutoff. To cut off triode and saturation, when we want to design amplifier by using MOSFET, then it should be in which region? Everyone please give me the answer. It should be in which region? Triode region or in saturation region? When we want to design amplifier by using MOSFET, then which is the triode or saturation? Now, to operate the transistor in saturation region, third question, for the device in B, find the value of VGS required to cause the device to operate as 1000 ohm resistor for very small value of VDS. Yes, when we are talking about the resistor, that is what? Voltage variable resistor, VVR. This is a VVR. Then we can change the voltage and the resistance will change. Then again we can use the MOSFET. Again give me the answer. In which region? Everyone please participate in comments and in the A and B answer. To design the amplifier in which region? Triode or saturation? For designing of the amplifier, MOSFET should be in what? Saturation region. But if you want to design a variable resistor, VVR, voltage variable resistor, then it should be in triode region, and value of the VDS should be very small, that is in linear ohmic region. So one by one we will solve all the questions. So use your calculator, copy, pen to note this. Now, first of all, what is in the question? Consider a process technology for which find COX and K and S. So COX is given by epsilon x by 2x, where this is epsilon naught upon oxide thickness. What is the epsilon R here for oxide? It is 3.9. Epsilon naught is 8.85 into 10 raised to power minus 12 farad per meter. This is the value of this upon. What is the thickness? Thickness is given as 8 nanometer. 10 raised to power minus 9. Then you can quickly find, use this your calculator, virtual calculator, then you will get the value. And this is 4.314 or 4.32 nearly equal to into 10 raised to power minus 3 farad per meter square, because it is the capacitance per unit area. So farad per meter square. Now normally what is the size of the MOSFET? It is in the range of micrometer. So Gajendra, how are you? It is in the range of micrometer. W is in the micrometer, L is in the micrometer, means area is in what? Micrometer square. W in micrometer, length in micrometer. So what is the area in micrometer square? The size is very small. Then we want the capacitance per micrometer square. So you can convert meter square in micrometer. So it will become 10 raised to power minus 3 divided by 10 raised to power plus 6 in 1 meter, 10 raised to power plus 6 square, that is converted into micrometer square. I have converted meter into micrometer, then it will become, capacitance will become 4.32 into 10 raised to power minus 15 farad per micrometer square. Now 10 raised to power minus 15 is called femtofarad, so it will become 4.32 femtofarad per micrometer square, and that is the answer for this question. The unit is very small value of the capacitance we are getting here, and that is called what? Oxide capacitance, right? So this is the first answer, oxide capacitance. Now second, what is the value of K and S? So in case of MOSFET, as you know, K and S is given by K and S, mu n COX. Remember, in saturation, the formula is 1 by 2. This is the formula 1 by 2. K and S. W by L. W by L is called aspect ratio. VGS minus VT. Threshold voltage, the whole square. That is the formula in saturation. Now, what is the unit of W by L? Unitless. What is the unit of half? Unitless. So, what is the K and S? Ampere per volt square. So, unit of K and S is ampere per volt square, or sometimes milliampere per volt square, or what? Microampere per volt square. From this you can get the value. Kn is equal to what? W by L is the unitless, and that is divided, and you will get this units. Now mu n COX. Mu n is given in the question 450, but always remember the unit. What is the unit? Centimeter square per volt second. Centimeter square per volt second. This is the unit. So COX should be in centimeter. So what is the COX? 4.32 femtofarad into 10 raised to power minus 15 per micrometer square. This is the 10 raised to power minus 15 per micrometer square. Convert it into centimeter. When I want to convert it into centimeter, so micrometer is 10 raised to power minus 4 square. This is what? Centimeter square. Why? Because this centimeter square and this centimeter square is cancelled out, and then you can find the value. You can multiply it and you will get the, because this is very important thing. Unit. What is the unit? That then you will get please use your calculator. (1.944 into 10 raised to power minus 4). Ampere per volt square, or it is 194 microampere per volt square. 194 into 10 raised to power minus 6 microampere per volt square. That is the value of K and S. Very easy question, formula based, but take care of what? Units. That's why I have chosen this question. Third question in the second, this is the first question, sir. First, for a MOSFET with W by L 8 micrometer upon 0.8, that is the ratio is 10, calculate the value of VGS and VDS minimum needed to operate the transistor in saturation region with a DC current of 100 microampere. So already I have given for saturation, what is the condition for the MOSFET? For saturation, VDS should be greater than or equal to VGS minus VT. So what is the VDS minimum? VDS minimum is called VDS set. Saturation. That is nothing but VGS minus VT, exactly equal to. So that is the minimum value of VDS for which the transistor will be in saturation. Now you can find in saturation IDS is given by half of K and S, W by L, VGS minus VT the whole square. You have to find a VGS minus VT, that is nothing but VDS minimum. What is the current is given? 100 microampere. What is the K and S? Already we have calculated 194 microampere per volt. We have find now 100 microampere that is given, and what is the K and S? We have find 194 microampere per volt square. Then W by L is 10. VGS minus VT the whole square. Now you can multiply and you can find the root of this. Take care of units again. Then you will find VGS minus VT is equal to plus root, we have to find the root of this value. This will become 200 divided by 194 into 10. This 2 is multiplied and that one. And you will get VGS. What is the value of the VT? 0.7. Plus minus. Always remember, you will get the two values because it is a root. So 200 divided by 1940, root of this value 0.32. 0.321. Now you can say, sir, VGS minus VT, that is the VGS minus VT. You have to choose the plus value. Why? Because when we are choosing the plus value, you will get the value greater than the threshold. Right, greater than what? Threshold. If you are choosing the minus value, the value will become less than the threshold. Less than threshold means it is in cutoff, because VGS should be greater than VT. That is the condition. You have to ignore the minus value, you have to choose the plus value. Now, so what is the VGS minus VT? That is called VDS minimum. So first answer, what is the VDS minimum required for saturation? 0.321. 0.321. Then what is the VGS required? 1.021. That second question is, what is the VGS? 1.021. That is the answer for this question. ID. Very, very simple. Third question, how we can solve. So already we have solved question on what saturation and what is how to find the COX, how to find the K and S. Then finally, for the device in part B, means W by L ratio remain 8 by 0.8. K and S is from the first part 194 microampere per volt. Find the value of VGS required to cause the device to operate as 1000 ohm resistor for very small value of VDS. What is written? Very small value of VDS. Then how we can find for VVR? Actually it is a voltage variable resistor. VDS should be very, very small. Why? Simply according to the characteristics, this is the characteristics of the MOSFET. First of all, it is follow the Ohm's law, bending of the curve, and then it will enter into the saturation. So here, this is the VDS and this is the IDS. For the small value of VDS, in this portion, it acts as for a linear ohmic region. It is in linear ohmic region, it acts like a resistor here. After that bending of the curve, then it will enter into what? Saturation. And this is the triode region. In a triode region, when the VDS is very small, this is the VDS very small, then it acts like a resistor. Here we have to find, so what is the formula here? IDS in saturation, in triode region, the formula is K and S W by L VGS minus VT into VDS minus 1 by 2 VDS square. Right. When this VDS is very small, this one, we can neglect this term. That is the formula in what? Triode region. That is the formula in what? Triode region. When this is very small, you can ignore this. Then IDS will become K and S W by L VGS minus VT into VDS. And then VDS upon IDS is called RDS, drain to source resistance. We have to find this resistance in linear ohmic region, that is given by K and S W by L VGS minus VT. So what is the name of the VGS minus VT? Any idea? Give me the answer in comments box. Okay. Then first RDS you have to find, but RDS it is given 1000 ohm. You have to find what? 1000 ohm. When it is in 1000 ohm, you can put here 1000 ohm. 1 by, what is the K and S? 194 microampere. Because it is in ohm, you can convert 194 microampere. It is converted into ampere per volt square. What is the W by L ratio? 10. and then you have to find a VGS. VT is what? 0.7. VT is what? 0.7. So put the value here and then you can find the value of what? VGS. VGS you can find, guys. Now from this, okay, watch this. PDF will be available on my Telegram channel. So please first of all focus on the board and how to solve, use your calculator and so on. If you want the VGS minus VT, that is the 0.7, then it will become 1 divided by 194 into 10 raised to power minus 6 into 10 into 1000. Right, this is the 1000 and it will become 100. This will become 100 divided by 194 plus 0.7. This is the value of VGS required for register. So what is the value? 100 divided by 194 plus what? 0.7. 1.21. 1.21. This voltage is required for voltage variable resistance, the value of 1000 ohm. Okay. So we have solved question on saturation, we have solved question on triode region, we have solved the question on what? VVR, we have find COX and KN DES. So this is the one question from standard textbook. You got the idea about all type of questions. Yes. So overdrive voltage, yes, you have given the right answer, that is called overdrive voltage or effective voltage. Overdrive voltage or effective voltage, that is called VGS minus VT. VGS minus VT because it is the effective voltage. Overdrive voltage, VOV. And always remember that when we are calculating VGS, if it is in a triode region or it is in a saturation region, it should be greater than VT, otherwise there will be no current. There will be no current. Okay, that is all about the first question. I think you have enjoyed this. Now, already that PDF will be available, right? Please go through my Telegram channel. Now, next question. Okay, then guys, remember what is the given here? Design the circuit of figure. They will give you the some circuit in textbook. What is the style? They will give you one circuit. What is written here? Design the circuit of figure 4.21. Where is the circuit? Here it is the circuit. इसमें design क्या करना है? So design the circuit means it is the language of any particular textbook. Design the circuit means already it is given to tell me which type of MOSFET, N channel or P channel. VDD is given battery 2.5. Here VSS is converted minus 2.5. Gate is connected to ground. But what is unknown here? RD and RS. To design the circuit means simply find the value of RD and RS for the given value of the current and given value of the battery value. Now tell me in which N MOSFET or P MOSFET. Now design the circuit so that a transistor operated ID is equal to 0.4 milliampere. The value of the current is given 0.4 milliampere. VD is given 0.5. The NMOS transistor has VT 0.7 volt. Again, just like a previous question. Mu N COX 100 microampere per volt square. Already I have given a unit. But remember, if the current is in milliampere, mu N COX is nothing but K and S. It is given 100 microampere per volt square. You can also convert it into milliampere divided by 1000. 0.1 milliampere per volt square. Why? Because the main current is given in milliampere. Aspect ratio, directly you can find W by L. 32 times this time. W is 32 times the channel length. 32. 32 micrometer, 1 micrometer, micro cancel, the ratio is 32, aspect ratio. Neglect the channel length modulation, assume that lambda is called channel length modulation parameter, so lambda is 0. Lambda, remember, lambda is equal to 1 by VA, volt negative, unit is volt negative, okay, early voltage. Now, This is the W by L 32. How you can find the value so that the transistor ID? Simply in this diagram, watch this. What is the VD given here? VD given here is 0.5. Okay, that is given in the question. VD is given in the question 0.5 volt. ID and VD 0.5 volt, ID 0.4 milliampere. Now directly you can find the RD. To find the RD, this voltage minus VD upon what ID? So you can find the value 2.5 minus what? 0.5 upon ID. What is the ID? 0.4 milliampere. So it will become 2 divided by 0.4 kilo ohm. Why? Because the current is in milliampere, resistor will be in kilo ohm. 20 by 4. So ID is equal to 5 kilo ohm. This is a very, very easy question. Na? Very easy. This one. First ID. But if you want to find the RS, suppose you want to find the RS, you can't write the KVL from this point because you have no idea about this value. What is the VDS? No idea. You can't write the KVL from this point to this point. Then you have to write the KVL, but here you have to find the VGS. And definitely this VGS is greater than VT. Why? Because there is a current. So when there is a current, always remember VGS is greater than VT. And this VGS is positive because it is a, you have not given me the name of the MOSFET. It is a N-channel MOSFET. N-channel MOSFET. N-channel, this is the arrow. So current enter through the drain leaving the source means it is the N-channel MOSFET. Source will provide the electron. When electron is moving inside, current is moving outside from the source terminal. It is a N-channel MOSFET. Now this current is moving, then VGS is greater than VT, positive value. If you want to find the RS, you have to apply the KVL. Now I am going to solve the RS. How we can find the RS? Watch this diagram. This is the for RS. Now here, here's what I found. VGS. Then you can apply the KVL from this point to this point. Apply the KVL. When I am going to apply the KVL, you will get 0 is equal to VGS plus ID into RS minus 2.5. This is the minus 2.5 volt. And then you can find IDRS is equal to VGS 2.5 minus VGS upon ID. That will give you the value of RS. Directly I am writing the value of RS. Okay? No. Now in this question ID is known 0.4, you have to find the VGS. But before finding the VGS, you have to find whether this transistor is in triode region or in saturation region. It is not in cutoff because there is current. So how we can find it is in triode region or saturation region? Always watch the value of VD here. Here the VD, it is given in the question 0.5 volt. Okay. Now what is the VG? VG is 0 volt. VD is 0.5 volt. VG is 0 volt. Watch this. This is the 0 volt. Disconnected to ground. So it is visible that VD is greater than VG. If the VD is greater than VG, means VDS is greater than what? VGS. VD with respect to ground, VG with respect to ground, VDS is with respect to source with respect to source. So automatically we can say that is the VDS is greater than what? VGS. Okay. When the VDS is greater than VGS, therefore VDS is greater than what? VGS minus VT. 100% sure. This is a VDS is greater than VGS minus VT. If it is, this condition is satisfied, means it is in MOSFET M is in saturation. MOSFET is in saturation. Why it is needed? Because current, you have to use the formula for triode or saturation. Now we can use the formula for what? Saturation. So what is the ID? ID is given by 1 by 2 K and S, that is mu n cu x, W by L, VGS minus VT the whole square. From where you can find a VGS? So ID is given as 0.4 milliampere. 1 by 2 K and S already we have converted into what? Milliampere. This is the first of all I have given. W, K and S 0.1 milliampere per volt. W by L is given as 32. You can put the W by L 32. And this is the VGS minus 0.7. VT is given as 0.7 the whole square. Then this will become, this is what? This is 0.1, 0.4, or you can directly, if suppose you find any difficulty, then directly you can multiply it. This is the 2.8 divided by 32 into what? 0.1 and root of this. That is nothing but VGS minus 0.7. Now this will become what? 8 by 32, 1 by 4, root of 1 by 4 is what? Plus minus 1 by 2. VGS minus 0.7. Already I have said that VGS is 0.7 plus minus 0.5. Remember, you have to choose the plus value, because when we are choosing the plus value, it is 1.2 and that is greater than VT. But if you are choosing the minus value, it will become 0.2. That is less than VT. That is not possible, because if it is less than VT, that it will be in cutoff. That's why answer is 1.2. So 1.2, now we have 1.2 volt, you can put here 1.2 volt. 2.5 minus 1.2 divided by 0.4, that will become 1.3 divided by 0.4, that is 13 by 4 kilo. I think 3.25. 3.25 is the answer for this question. 3.25. So that is a, so in this question you have to decide whether the MOSFET is in triode region or saturation region, because once you have idea, then you can use the formula. So that is in what? Saturation region. This is the question. Okay. Now this is another question from the standard textbook. Redesign the circuit in example 4.4 to double the value of ID without changing the VD. Give new value for W by L and R. That is the question. This is, I have the textbook. Now I am going to give you the page number also. I think you have this textbook, everyone. This is the Sedran Smith volume 6, 6th edition, and I am solving question from this, and that is the chapter number 4. The chapter number 4, you can go through the chapter number 4, guys, where number of questions on MOSFET. Just I have given, that is the example D 4.10 means what? This is the numerical you can solve. Some exercise, some examples are given. Okay. And you can go through the diagrams also. 1 minute. Yes. Redesign the circuit in example 4.4. So where is the example 4.4, and that is the diagram, guys. And just I am giving you the diagram here. Watch this. This is given grounded. This is connected here. RD is given, and in this diagram, this is VDD is given as 3 volt. This ID is given, because what is the current through the gate terminal? 0. And this is only given 3 volt, and this is VD is given. Now, redesign the circuit in example to double the value of ID. So what was the value of the ID in example 4.4? That is the 80 microampere. 80 microampere. Remember, initially it was the 80 microampere. Now this is required 160 microampere. That is the question given here. And value of redesign means find the value of R. VT 0.6 mu n CUX 200 microampere per volt square. VT 0.6 volt. K and S, that is nothing but mu n CUX 200 microampere per volt square. You can convert it into milliampere, 0.2 milliampere per volt square. Right, mu n CUX. L 0.8 W4 0.8 micrometer. Width is given as 4 micrometer. What is the ratio, aspect ratio? Everyone tell me. Width 4 and 10. 10 that is given. Or what is there? Neglect the channel length modulation means lambda is 0. So you have to find double the value of the current. In example, it is given 80. So you have to double it. So double means 160. Like this is the 160 microampere. Simple. This is the question. For ID is equal to 1. What is the simple language in GATE exam? ID is equal to 160 microampere. What should be the value of RD? Right, and what is the value of the VD? You have to find two things. Find the value of RD and VD. Right, without changing the VD. Give the new values for the W by L and what? R. So that is given. So in a previous question, first of all, ID is given as 80 microampere. Everything is given. For this, you have to find the value of VD and RD, then we can solve this question. This is the example number 4.4. Example 4.4. So we will solve this question and then that one. Okay, example. Very good evening, Ashish. How are you? For ID is equal to 80 microampere, VT is equal to 0.6, mu n CUX is equal to this. So what is the value of RD and what is the value of the VD? Now, always remember, when drain is connected to gate, then this voltage, this is called VGS. This is called VGS, VDS and VGS. Since drain is connected to gate, means what? Solution. VD is equal to VG. Both are equal because they are connected, short circuited. When both are equal means what? VDS is equal to what? VGS. These are also equal. Means what? VDS is greater than what? VGS minus VT. We are subtracting something from VGS. And that's why that is greater always. Means what? MOSFET is in saturation region, not in triode region. MOSFET is in saturation region, not in cutoff. Why not in cutoff? Because there is current 80 microampere. So this is the example 4.4. Then we will solve this question. Now, if it is not in cutoff, then how we can solve this question? For this diagram, this is the standard diagram. No need to check. If the drain is sorted with the gate, it is in saturation. Now, VGS is nothing but VDS. If you want to find the value of RD, ID is given, you have to find the VD. RD is nothing but 3 minus VD upon ID. And VD is what? VDS. VD is VD. VDS is VD. Now, write down the formula. Half of K and S W by L VGS minus VT the whole square. VGS is the VDS and VDS is the VD. ID given 80 microampere. It is given in the question 80 microampere. K and S mu and CUX, it is given 200 microampere. Into W is given as 4 and 0.8. You have to find the VGS. VT is given as 0.6. Now, that will become this 0 cancel out. Okay, no problem. And now this 2, that is 10, it will become 10 into 4, it will become 40, and it is 8 into 0.8 divided by 40. Root of this will value of VGS minus 0.6. Now that will become 0.8 divided by 2, I think 0.4. Please check my calculation. 8 into 8 is what? 0.4. You will get plus minus 0.4. Ignore the minus value because it will make the VGS less than VT. So what is the value of the VGS? 1 volt. That value of VGS is nothing but value of VDS. That is the value of what? VD, because VS is 0. Because this is 0. This is the value of VDS or VD, same thing. That is 1 volt. Now you have the 1 volt, then you can find the value of RD. 3 minus 1 upon 80 microampere minus 3 milliampere. It will become 2 into 1000 divided by what? 8 T. This 0 cancel. This is 100 by 4. 100 by 4 is what? 25 kilo ohm. Answer is what? 25 kilo ohm. Assis, are you getting this point, everyone? So that is the answer for this question. 25 kilo ohm. So these are the standard question from what? Standard textbook, guys. Standard question from standard textbook. Okay. That is the answer. Now, what is given here? What is given here? This is the example. Now, what is given? Redesign the circuit. In the example, redesign the same circuit to double the value of ID without changing the VD. Means VD is fixed 1 volt. ID you want, VD is fixed 1 volt. ID you want double. 80 microampere, double means what? 160 microampere. According to new question, this is what? 160 microampere. VD will remain 1 volt. Give the new value of R and W by L ratio. W by L, aspect ratio. That is a very, very important. We can change the aspect ratio. Then what is the answer here? Now, watch this. If you have this diagram, same diagram here. Suppose it is not possible to change the value of VD. VD is 1 volt. And that's why VG is also 1 volt. This voltage is fixed. VGS is fixed 1 volt. Now RD, and that is the 3 volt, it is also fixed. But current is what? 160 microampere. You can find a new value of RD. What is the new value of RD? Current double, voltage remains same. So resistor half, 3 minus 1 upon 160. Microampere, convert it into milliampere. That's why you are going to read the resistor in what? Kilo ohm. So that will become 2 into 1000 divided by 160. Now you can find that will become what? 8. So 100 by 8 means what? 12.5 kilo ohm. 12.5 kilo ohm. You can reduce the value of the resistor first of all. Then second thing, W by L ratio means always remember when the drain is connected to the gate, it is in saturation. Directly you can use this formula. ID is equal to half of K and S W by L. This time you have to find a W by L. VGS minus VT the whole square. They will change the language. But remember, 160 microampere. 1 by 2. What is the K and S? 200 microampere. This is in micro, this is in micro cancel. You have to find the aspect ratio W by L. VGS is fixed, just like a previous question. VT is fixed, the whole square. Can you find the W by L? Very, very easy one. So this is the 2 into 16, that will become 32. 32 divided by 20. 32 divided by 20 into 1 divided by 0.4 square. That will give you the value of W by L ratio. You can check and you can give me the answer. Yes, everyone tell me what is the answer for this question. So this type of question, they will change, but formula almost will remain same. That is not too tough. You can solve, but you have to avoid what? Calculation mistake only. Then divided by 0.16, 10. W by L ratio is what? 10. Initially it was 5. Now you have to just double the W by L ratio. Okay. Very, 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 very simple question, guys. Okay. Easy. The next one. So you will get the answer 10. So what is the difference between the BJT and it may be of 2 marks, Asis, it depends. What is the difference between the BJT and this one? In a BJT, we are not talking about the physical dimension of what? Transistor. For example, we are not talking about in any numerical, that is the width of the BJT, that is the length of the BJT. Yes, no. In the formula, simply we are using IC is equal to beta IB, IC is equal to beta IB plus 1 plus beta ICO and so on. But in MOSFET, that depends upon the size of the MOSFET, W by L. Or when we are doubling the size W by L from 5 to 10, automatically the current will double. Automatically the current will double. So that is the reason. So that's why they have given this question. And when we are changing, the current is doubled, and if you want to maintain this voltage same, you have to reduce the value of the RD. So RD will become half. Very simple question. Now, then one question on what? Current mirror circuit, guys. One question on current mirror circuit. Current mirror circuit is, we can design the current mirror circuit by using BJT as well as by using MOSFET. Last year in 2023, there was a question on current mirror circuit. And last year again, there was a question on the current mirror circuit. So this is a very, very simple current mirror circuit by using the MOSFET. 20 kilo ohm resistor is connected here. VD 3 volt means this is the 3 volt, this is the 3 volt. And which one is the driver here? Actually, this is the driver. Driver means which one is the reference voltage and which one is the load resistance. This is the reference voltage. Because that is connected to what? This one. This is connected here, means that definitely it is in what? Saturation. It is in what? Saturation fixed. Because when the drain is connected to gate, it is in saturation. Now remember, from this point to this point, voltage for both this MOSFET and that MOSFET is similar. Now what is given? Consider the circuit of figure 4.22, which is designed in example 4.4, which you should refer before solving this problem. Let the voltage VD be to applied to the gate of another transistor Q2. VD to be applied to gate of another transistor Q2, gate of the another transistor Q2, as shown in the figure. Assume that Q2 is identical to Q1. Find the drain current and voltage of the Q2. Find the drain current and voltage of the Q2. And what is given? Consider the circuit of figure 4.22 as in design in example 4.4. That is, circuit is designed. What was the value of the VD here? Already we have find the VD 1 volt. Already we have find the VD 1 volt. Now this VD is connected here. Where it is connected? Here. This VD is applied to the gate of another transistor Q2. Means this VGS will become 1 volt. And the threshold voltage is 0.6 volt. Assume that Q2 is identical to Q1. Find the drain current and voltage of the Q2. Drain current and voltage of the Q2. Okay. Now, it is a current mirror circuit. So, I will give you the idea about the current mirror circuit first of all. Then, this is the I reference. And here if you have the voltage VGS, because it is in saturation, if its W by L ratio is, like this is the W by L1 and this is the W by L2, all other parameter K and S are identical, right? K and S are same because it is an N-channel MOSFET. Then you can find the I reference is equal to half of K and S W by L of 1 VGS minus VT the whole square. By using this formula, you can find the value of I reference. Now, what is the value of the current through this MOSFET? That is the I2. I2 is given by I2 1 by 2 K and S. This is also same. 1 by 2 is same. W by L of 2. VGS is same. Why VGS is same? They are connected in parallel. So VGS is same. VT is also same. The whole square. Now divide those two equations. So you will get I2 upon I reference is equal to nothing but W by L of 1, 2 upon W by L of 1. That is the ratio. You have to use this ratio only. Because remaining things are same, they will cancel each other, and that is. Now it depends. Or if these ratios are also same, then you can say I2 is equal to what? I reference. I2 is equal to what? I reference. Use this formula only. And what is given here? VD. VDS is given as 1 volt. So you can use this 1 volt. If the VT is given, W by L is given, you can solve this question. So that is the current mirror circuit. So go through the previous year question, number of questions on current mirror circuit, guys. And that's why I have chosen this. But simple ratio. That is the two formula. Both should be in saturation region. Okay. And always what? They have the same voltage here. They are connected in parallel here. Once the drain is connected to gate, that will be in saturation. This will be also in what? Saturation. Identical characteristics. Now, next question. Next question. What is given here? Design the circuit in figure 4.23. We have one circuit to establish a drain voltage of 0.1 volt. 0.1 volt is very, very small. But we will check. It is not talking about the VDS. It is talking about what? VD only. VDS you have to check whether it is small or large, but it is VD is 0.1 volt. What is the effective resistance between the drain and source at this operating point? Like VT is 1 volt, K and S, W by L. Completely K and S, W by L is given 1 milliampere per volt square. So normally in gate exam, they will say this is the Kn. Some students are confused. K and S, W by L completely is called Kn. Okay, no problem. What is the K and S? Mu and Cux. They will mention aspect ratio. Actually, aspect ratio is included in this. Separately, aspect ratio is not given. That is what the complete value and unit is also same. 1 milliampere per volt square. 1 milliampere per volt square. Normally, what was the K and S? K and S was in microampere per volt square, 194 microampere, 200 microampere, 100 microampere. But when it is multiplied with the W by L, it is converted into what? Milliampere per volt square. So you can check the values. Now, what is the diagram here? This is the diagram. 5 volt it is given, RD, VD is 0.1 volt. Design the circuit means what? You have to find the value of RD only. This is the 5 volt, this is also the 5 volt. So VGS will become directly 5 volt. Watch this. VGS directly 5 volt. Because it is 5 volt, it will become 5 volt. VGS, VG minus VS, that is 5 minus 0, it will become 5 volt. And what is the VDS? VD minus VS, that is, what is the VD? 0.1 minus 0, that is the 0.1 volt. Very, very small. And what is the VGS minus VT? 5 minus, what is the VT given in the question? VT, threshold voltage 1 volt, it is given in the question. Minus 1, that is the 4 volt. Effective voltage is 4 volt. And watch this, VDS is very, very small as compared to VGS minus VT. When the VDS is very, very small, means it is in linear ohmic region. Triode region, and again in triode region, it is a linear ohmic region. And VGS is greater than the threshold voltage. VGS is greater than the threshold voltage. So what is asked here? Design the circuit means you have to find the value of the RD. What is the effective resistance between drain and source? At this operating point you have to find. Means you have to find the RDS also. VVR, voltage variable resistor. VVR. Then, to solve this question, Normally they are not asking a question on this, but remember, register VVR. In a triode region, we can write the formula IDS is equal to K and S W by L VGS minus VT into VDS minus half of VDS square. That is the formula. Then you can put all the values. IDS is equal to K and S. What is the K and S? It is given mu and COX. W by L 1 milliampere per volt square. This is completely given as 1 milliampere per volt square. What is the VGS minus VT? Already we have calculated 4. This is given as 0.1. This is given as 0.1 square. That's why this has become very, very small. You can say IDS is equal to 1. This will become 0.4 minus 0.1, 0.01 divided by 2, 0.005. Then IDS will become 0.4 minus 0.005. So I think it will become 0.3995. 0.395. 0.395 milliampere, nearly equal to 4 milliampere. If suppose you are going to ignore this, then we will get IDS nearly equal to what? 0.4 milliampere. Okay. Now once you have the value of ID, you can find the value of RD. 5 minus 0.1 upon ID. So what is the ID here? RD here. 5 minus 1.1 upon what? ID. That will become 4.9 divided by 0.4 kilo ohm, because it is in milliampere. Now you can find the value. 4.9 divided by 0.4, 12.25 kilo ohm. Okay, this is the value of RD. Now, what is the drain to source resistance? Drain to, yes, AK, your answer is correct. Drain to source resistance means this is the drain and source terminal. So what is the resistance between these 2 points? You have the voltage VDS. VDS is nothing but VD, 0.1 volt. You have the current. So what is the drain to source resistance? That is called RDS. VDS upon IDS. So when VDS upon IDS, so what is the VDS? 0.1. What is the IDS? You have calculated 0.395. Then you can find a value. 0.1 divided by 0.395, and this is 0.253 kilo ohm. What is in ohm? 253 ohm. That is the value. Otherwise, what is the standard formula for VVR when the VDS is very, very small? You can also find directly RDS is equal to 1 upon K and S W by L VGS minus VT the whole square. That is the formula. Okay. So this is what given. K and S. What is the K and S? It is given. K and S W by is given is 1 milliampere per volt. What is the VGS is given? 5 minus 1 the whole square. 5 minus 1 the whole square. You will get 1 divided by what? 16 kilo. Find the value. That is the formula, na? Yes. No. That is not the square. Sorry. VGS minus VT only. Not a square. Not a square. VGS minus VT only. Then it will become 1 by 4. 0.25. 0.25 kilo. So what is the answer? 250 ohm. Yes, we are getting slight difference. What is the difference here? Here we are getting what? 253 ohm. Where we are getting the 250 ohm. Because what we are doing when we want the voltage variable resistor, actually we are ignoring this. We are ignoring this and we are finding the IDS upon VDS or VDS upon IDS. So we are getting the formula VDS upon IDS is equal to 1 by K and S W by L VGS minus VT. When we are ignoring, then we are getting this formula. So approximately okay. They will give you the range. they will give you the range for that RDS. So always watch in numerical answer type question, they will ask what is the approximated value. Then this is a very, very small, then you can ignore it and then you can use this formula. Otherwise, if you have the value, for example, in this question, directly go for what? Exact one. So you are getting the 253 ohm. Okay, so this is again example from, now tell me, we are getting variety of questions from the standard textbook, yes or no? Now at the same time, when we are solving, so there are 2 or 3 strategies to get the good rank in any competitive exam. First of all, go through your short notes, detailed notes, formula notes. Second, solve questions from previous year question paper. Why? So that you will get the idea about the pattern of the exam and it will boost your confidence that okay, we are able to solve the previous year question that is designed by IIT or ISC. Third important thing, solve some questions from what? Standard textbook. So we are solving some questions from standard textbook. Fourth, what? Questions from workbook. So already we have provided some workbook. You have some workbook. Workbook means designed by the experts. You have some selected questions. Yes, you can go through it. Then finally try to give what? Mock test, and that is the time to give the mock test. So all India open mega mock test for GATE 2024 for all branches from 25th November to 1st of December. Register now. Link is given in description. First of all, install what? BYJU'S exam prep app. और मॉक टेस्ट जरूर दीजिए. मॉक टेस्ट आपको ना कॉन्फिडेंस आएगा कि क्वेश्चन बन रहा है या नहीं बन रहा है आपसे. तो लिंक आप डिस्क्रिप्शन में अभी जाएंगे तो आपको मिल जाएगा यूट्यूब डिस्क्रिप्शन में. यू विल फाइंड द लिंक एंड दैट इज द शेड्यूल गाइस. तो इन शेड्यूल यू विल गेट द आइडिया दैट देयर विल बी 65 क्वेश्चंस, राइट, 3 hours ड्यूरेशन, 100 मार्क्स, जस्ट लाइक एग्जाम लाइक पैटर्न. ओके, तो एकदम ऐसा लगेगा एग्जाम आप दे रहे हो, कंप्यूटर बेस्ड टेस्ट. तो आप कितना फास्ट कैलकुलेशन कर पाते हो, आंसर गलत लिख रहे हो या सही लिख रहे हो, जैसे राइट, तो क्या क्या सिली मिस्टेक्स होती है, यू कैन अवॉइड इट बाय गिविंग द मॉक टेस्ट. तो दैट इज द शेड्यूल फॉर इलेक्ट्रॉनिक्स ब्रांच. नाउ नेक्स्ट क्वेश्चन. नाउ नेक्स्ट एग्जांपल, analyze the circuit shown in the figure 4.24a. what is the circuit here? This is the circuit. 10 mega ohm resistor is given. Analyze the circuit. So first of all we will analyze VD 10 volt it is given, 10 volt it is given. This is a potential divider circuit, 10 mega ohm, 10 mega ohm. RD is given as 6 kilo ohm, RS is given is also 6 kilo ohm. And always remember what is the current entered through the gate terminal. Current entered through the gate terminal is 0. Why? Because it is a SiO2 layer. Because of that it is called insulated gate field effect transistor. There is no current. So if suppose there is a I current, same current will flow like this from this point to this point. Then RD is given. So according to voltage division you can find the value of voltage and RTH here. Then you have to find the voltages at all the nodes and the current through all the branches. Let Vt is 1 volt, Kn dash W by L is 1 milliampere per volt. Again this is given as Kn. Neglect the channel length modulation, lambda is equal to 0. There is no channel length modulation. We have no idea whether it is in what triode region or what in saturation region. Then you have to decide. Now what we can do, first of all, we can apply what? Thevenin's cut. Then you will get this is the gate Thevenin's voltage here. This is the 10 volt mega 10 mega ohm. Now when then 10 and 10 mega ohm, so what is the VTH? VTH is just 10 divided by 10 plus 10 R2 upon R1 plus R2 into VDD. It will become 10 divided by 2, 5 volt. This is the 5 volt. And what is the RTH? 10 parallel with the 10, that is the 5 mega ohm. No need to find the RTH because Ig is 0. Now you can convert this diagram . This is the VTH. What was the VTH? 5 volt. What is the RTH? 5 mega ohm. This is called RG. This is what is the gate current? 0. Now this is the RS. This is RD, and that is the 10 volt. Okay. RD is given 6. This is given 6. Now this voltage, no idea. VGS. There will be current ID. Same current will flow here. From this point to this point, that same current will flow. And then this is called VDD actually. This is the 5 volt. Now, what about the transistor? Whether it is in what triode region and saturation. So normally what we are doing, we are assuming let it is in saturation. When we are assuming let it is in saturation, then you can apply the VGS here in this loop. When we are applying the KVL in this loop, you will get minus VDD. This is the minus VDD, means minus 5 plus VGS. Because what is the current here? 0. There is no drop across 5 mega ohm, plus ID into RS is equal to 0. This ID into RS is equal to 0. So what is the VGS general formula? Remember, VDD minus ID into RS. VDD minus ID into RS. Now what is the value of the VDD? 5. What is the value of RS? 6 ID. That is the value of the VGS. 5 minus 6 ID. Now if you are assuming it is in what? Saturation, then you can use this formula. ID is equal to half of K and S W by L VGS minus VT the whole square. When we are considering the channel length modulation, there is a formula lambda VDS. This is with the channel length modulation formula. But lambda is 0. You have to neglect the channel length modulation. So simply focus on this formula. This formula only. Because lambda is 0. So what is the IDS? You have to find the IDS or ID. Just you can write ID or IDS. No problem. This is the ID. Then half. K and S means mu and COX. What is given? The mu and COX. Already mu and COX, W by L, everything is given as 1 milliampere per volt. VT is 1 volt. 1 milliampere complete. VGS, in place of VGS you have to put the value 5 minus 6 ID. 6 ID minus VT. VT is given as 1 volt square, and this term is 0. That's why it will become 1. Lambda is 0. No channel length modulation. Neglect channel length modulation. Then it will become 2 ID. Here you will get 4 minus 6 ID square. Now guys, you will find a quadratic equation here, right? That is the 16 minus 6 into 4, 24. Wow, 1 minute. 6 into 4, that is the 24. And then what is the value here? 48 ID minus 36 ID square. That is the quadratic equation. Now if you want, then you can divide it by 2. It will become ID. It will become 8. It will become 24 ID. And it will become 18 ID square. It is divided by 2. And that is the equation. Now you can arrange it. You will get a quadratic equation here. This is 18 ID square. 18 on right hand side, right to left. That's 24 plus 1, 25 it will become. Please check my calculation also. 25 ID minus it will become plus, minus 8 is equal to 0. Now what are the roots? So you can find the ID minus B, 25 plus minus root over B square. 25 square minus 4AC, minus plus 4 into 8 into 18 divided by 2A. Divided by 2A, 18. Okay, but remember ID should be what? Positive value. ID should be positive value. Tell me what is the answer. So you will get 34.65 root of this. Minus 25 plus minus 34.65 divided by 36. Guys, you have to choose the positive value because current is not negative. Current will flow from drain to source. So when we are taking the current positive, so that ID will become minus 25 plus 34.65 upon 36. That is 0.268. 0.268 milliampere. Now 0.268 milliampere. What is the meaning of this? 0.268 milliampere. Now you have to check. You got the answer, right? 0.268 milliampere. But we have to check whether this answer is right or wrong. How you can find? Right? Tell me. So first of all, check all the carefully check all the calculation here, right? Then we are getting, this is the equation, 5 minus 6 ID, that is the value of the VGS. Yes, it is correct, minus 1. 5 minus 6 ID put here. 5 minus 6 ID minus 1, the whole square. You will get 2 ID, that is the 4 minus 6 ID. Okay, the whole square. Then this is the 2 ID, this will become 16 minus, okay, and that is what? Okay, that is wrong. No, it is plus, guys. This is the calculation mistake. This is plus here. Now if it is plus, then there is a change in the quadratic equation, which is the 18d square. Then it will become minus 25 here. This is called calculation mistake. Minus 25 here, because that is the plus. Square is what? Plus here. This will become minus 25 and that will become plus 8. Plus 8. Now minus b, okay, that is the equation. Minus b plus minus b square minus 4ac. This now it is negative. This has become plus 25 square minus 4 into 8 into what? 18. 4 into 18, now it is correct. 2 into 18, that is also correct. Yes, there is a problem. Okay, no problem. This is now already I got the calculation mistake here. Now what is the answer here? That will become 25 plus minus. Now this is the value. 4 into 8 into 18. 576 minus 25 minus 625. 49, and what is the root of the 49? 7 upon 36. Now you can find the two values of R. So normally we are doing what? Silly mistakes. So when we are solving question, we can avoid this type of silly mistakes. Now you have the value of ID. 25 plus minus 7 upon 36. If suppose I am taking the minus, so it will become 25 minus 7. 25 minus 7 is 18 by 36. You will get the 0.5 milliampere. If you are choosing the plus, it will become 32 divided by 36. Right? So 32 divided by the 8 by 9. So what is the 8 by 9? So 32 divided by 36. 0.8888 milliampere. Now which one is correct? Because you have assuming that it is in what? Which region? Assuming that it is in what? Saturation region. So for saturation region, what should be the value of VDS? It should be greater than VGS minus VT. So what is the value of the VDS? It should be greater than VGS. VGS is fixed. You have chosen the if you are choosing the 0.5, then what is the VGS? 5 minus 6 times of ID. So when I am choosing the 5 minus 6 times of ID, the 5 minus 6 into 0.5, that will become 5 minus 3, that is the 2, and that is greater than VT. Okay. But when we are choosing the VGS, 5 minus 6 into 32 by 36, 32 by 36. Then it will become 6, 32 by 6. What is the 32 by 6? 32 by 6. That will become negative value. My dear friend, negative means what? Negative means not in, it is in cutoff, less than VT. That's why you have to choose the value 0.5. This is neglected. Because for this, VGS will be less than what? VT. VGS will become less than VT. Then you have to choose what? 0.5 milliampere ID. Now, 0.5 milliampere is the ID. So, what is the value of VDS you can find? What is the value of VDS you can find? You can write. This is the 10 volt. What is the drop across this? 3. What is the drop across this? 3. 3 minus 3. 10 minus 6, you will get the VDS 4 volt. Or you can write the KVL from this point to this point. 10 is equal to 6 into 0.5 because ID is 0.5 plus VDS plus 6 into 0.5. So this is 3, this is 3. So what is the value of the VDS? 10 minus 6, that is the 4 volt, and this 4 volt VDS, it should be greater than VGS minus VT. Yes, it is greater than VGS minus VT because what is the value of the VGS? 2 volt. Value of VGS is 2 volt, and that's why this value is greater than VGS minus VT. That is nothing but 1 volt only. So our assumptions is correct. It is in which region? Saturation region. So that is the question, potential divider and how to find the unknown current, quadratic equation. Please try to avoid, and when we are getting the 2 answers of quadratic roots, then how we can neglect one answer and which one is the correct? You have to find the threshold voltage, and it should be VGS, and it should be greater than what? Threshold voltage. Otherwise you will get the wrong answer. So in this way you can check. Now it is time for homework. So already I have solved. Now this is the question. For the circuit of figure, what is the largest value of that RD can have while the transistor remain in saturation mode? Same diagram. This is the diagram. For the diagram, you can join my Telegram channel where you can find this diagram and then solve this question and give me the answer on my Telegram channel. Second question, redesign the circuit of figure, same diagram for following values. Again, this is the homework. So 2 questions as a homework. Then if you are giving the mock test, guys, so what are the benefits of mock test? You will get the leaderboard. Leaderboard means how many number of students participated in this, what is the name of the student, what is your score, what is your rank. But first of all, you have to install what? BYJU'S exam prep from Google Play Store. Install kijiye free of cost app and try to give the mock test. Free mock tests are also available and you can join also. So for more detail, first of all install, and then if you want to start your journey with us, okay, then you have opportunity. First of all, give the scholarship test, and these are the running courses, GATE 2024 crash course as well as GATE 2025-2026. We have started for all the branches, ESE and GATE, electrical electronics in English as well as in Hindi. लाइव क्लासेस, रिकॉर्डेड लेक्चर, स्टडी मटेरियल, प्रैक्टिस क्विजेस, मॉक टेस्ट. यही तो 5 बातें हम बताते हैं कि इनको फॉलो कीजिए, आपका रिजल्ट्स आ जाएगा. एंड हाईली क्वालिफाइड एंड एक्सपीरियंस फैकल्टी मेंबर्स आर हियर. सिंपली कॉल एट दिस नंबर. ओके देन, थैंक यू वेरी मच फॉर अटेंडिंग द सेशन. दिस इज माय चैनल इलेक्ट्रॉनिक्स बाय संजय राठी. यू कैन ज्वाइन नाउ. ओके देन. तो इसरो का भी डेट आ गया भाई, 17th of December. If you have any suggestion, if you want anything, then write on my comments box, and we are going to start some important useful session for you. So like the session, share the link of this session and subscribe our channel so that you will get the notification about coming session. Thank you.
You don't need to